Hi guys. So as promised, we are going to go through domain and range again this week. Um, I'm really the best way to show you is to just kind of do some examples. So I'm going to start by saying whether or not it's a function. So if you remember, the way you can tell if a graph is a function is something called the vertical line test. So if there is anywhere where I can draw a vertical line up and down where it touches more than one point on the graph, then it is not a function. Okay, so you're just looking for anywhere where the x's kind of overlap on each other. For points, for domain and range, the simplest way to do that is to make a table, right? Because remember, domain is all the x's, and when it's points, it's specific x's and y's that are part of the domain and range. So I'm just going to make a list, but only when it's just dots that are not connected. Okay, so I'm going to make a list of all my points. So I've got the point 1, 2, the point 2, 1, 2, 3, and 3, 2, 5, and then the point 4, 2. So for domain, that's my x's. I'm just going to list them from least to greatest inside what are called braces. They're the fancy, like squiggly parentheses. So, and I don't have to repeat myself. So it's just 1, 2, and 4. Those are the only possible x's that could show up. Okay. For my range, I'm going to list the y's from least to greatest inside braces. So I'm going to have 1, 2, 3, and 5. Again, I don't have to repeat myself. So it's just those specific ones. Now, when you have a continuous graph like this one, the same rule applies for whether or not it's function. I'm still looking for if there's anywhere I can draw a vertical line where it touches more than one point. Doesn't matter where I draw vertical lines, everywhere, it'll only ever touch one point. So yes, it's a function. For domain, I'm looking for a boundary from left to right because domain, remember, is my x-axis, which goes left to right. So for domain here, if you'll notice, both left to right, there are arrows. So if there's arrows going in both directions, whether you're talking left to right or up and down, that's when you use all real numbers. Okay. For my range, I'm looking, there's no boundary at the bottom, right? But there is a boundary at the top. So for my y's, because the y-axis goes up and down, there's a boundary at 4. And since all of the points are below 4, I'm going to say that y is less than or equal to 4. So you're just looking for a boundary, and then you're saying is the graph above or below it. Okay. So for this well, not last one, but for this one, vertical line, no matter where I draw, only ever touches one point at a time. So yes, it's a function. For domain, looking for left and right boundaries. Well, it goes forever to the right, but nothing goes past this point on the x-axis. So my boundary is going to be 1, because when x is 1. And since it's to the right of it, it is greater than or equal to 1. Okay. So you're finding a boundary and seeing is it bigger or smaller. For y's, I'm looking for upper or lower boundaries. It goes down for forever, but nothing, it's never going to go above this point on the y-axis. It's never going to go above 2. And all of the points are below that, so I'm going to say less than or equal to 2. Okay. For this one, vertical line test still applies. No matter where I draw a vertical line, it only ever touches one point. So yes, it is a function. Then I'm still, for my domain, looking for left and right boundaries. So these are dots, they're not arrows. So it does not go past this point to the left or this to the y. So that means that I have two boundaries. So I'm going to put x in the middle. Now the furthest it goes to the left is -6. And the furthest it goes to the right is 1, 2, 3, 4. And I'm gonna, whenever we put x in between two numbers, we always use less thans, okay? So when you have two boundaries, it's gonna be a compound inequality with either x or y in the middle, and then your boundaries on either side with less than or equal to. For my y-axis, there is a lower boundary because there's no arrow down there. So this is the lowest it goes, and this is the highest it goes. I know it's hard when we're doing digital. Not everybody can print things off or write on a tablet, but it really helps if you kind of draw the boundary lines when you're doing these. Because now I can see like the lowest, nothing goes below, -9. Put y in the middle. And the highest it goes is 7 with less than or equal to on either side. Okay, so remember, if there's no arrows anywhere and it just goes like from here to here, compound inequality. All right, for this one, vertical line test. So yes, there's lots of places I can draw vertical lines where it touches more than once, right? So I'm gonna say, no, it's not a function, but I can still do domain and range. So my domain, I'm looking for a boundary to the left or the right. Well, right here, it's never gonna go past that point. So my boundary is at 2. And since it goes to the right, all of my x's are greater than or equal to 2. For my range, it goes up for forever and down for forever. So my range, is going to be all real numbers because there is no upper or lower boundary. When there's not a boundary, all real numbers. And then for the last one, vertical line test. If I draw lines in these places, it touches more than once. You only need one place where it does that, but obviously it does it more than once. So no is not a function. Then for domain, looking for left and right boundaries. So the furthest left it goes is 0, and the furthest right that it goes is 4. So I'm going to say 0 is less than or equal to 4. 0 is less than or equal to x is less than or equal to 4. For range, I'm looking for a lower boundary, which I have. Nothing is below that point. Or an upper boundary, which I have because nothing is above that point. So the lowest it goes is -2, and the highest is +2. Range is y. So that is what my compound inequality looks like. So domain and range, remember you're describing what all the possible x's or y's are from a graph. It is a tricky concept, but once you get the hang of it, it's really not that bad. So it really just takes practice. So make sure you're doing the homework and watching the videos and coming to the live meets where we're doing problems together.